In the previous lesson, you learned about how to make decisions in your program using if one way, if else two way, as well as chains of if else multi-way statements. Sometimes, not always, you can convert an if else chain into a switch case statement. Say you are trying to convert a character into Morse code, and you want to output the dot-dash equivalent of the letter. For simplicity, let's just use the first few letters of the alphabet. In Morse code, A is dot dash, B is dash dot dot dot, C is dash dot dash dot, D is dash dot dot, E is dot, F is dot dot dash dot, and G is dash dash dot. The if-else chain in this example is not too bad, but it is only a portion of the alphabet. The entire code would take much more room and get very long and complicated. For the input letter B, it first fails the letter A test, so drops down to the letter B test, which is true, and it outputs dash dot dot dot. The A input passes the first test and outputs dot dash. The D input fails the A, B, and C test, finally matches the D, and outputs dash dot dot. A better way to do this would be to set up a multi-way decision process using the switch case statement. In some ways, this is a better, more organized, and more readable way to control multi-way decisions in Java. See the next few slides for the Morse code example using a switch case statement. This switch case program accomplishes the same thing as the previous if-else chain program. As you can see, the output is identical. Let's look at it carefully. First of all, the input process is the same. A character is input from the keyboard. The process now changes. The overall structure of the switch case statement begins with the word switch, followed immediately by a parameter, in this case, let. The let parameter contains the value to be switched into the desired outcome, in this situation the equivalent Morse code output for the character contained in let. The compiler compares the contents of let to each case in the selector list on the left until it finds a match. Once it finds a match, it jumps the fence or crosses over the colon to the right side of the statement and executes the command shown. Once it executes the command, it sees the word break, which causes the whole switch statement to stop. The program then continues on after the end of the switch statement. It is a fairly simple process, really. However, there are some pitfalls that happen sometimes. The most common mistake for beginners is to forget to put the break statement after each line. Look carefully at the different outputs when no breaks are included in the switch statement. G is output, and we get dash dash dot. That's correct. G was the very last one in the selector list. F is input, and we get two results, the one for F, dot dot dash dot, and the one for G, dash dash dot. That's not what we want. We input the letter A, and we get all 7 outputs. That's not definitely what we want. What the heck is going on here? The answer is simple. Once the compiler jumps the fence after finding a match, it executes everything it sees until it sees a break, or until it reaches the end of the statement. In the first example, since the letter G was the last item in the list, there was only one output before the compiler reached the end of the statement. Therefore, only one thing was shown. However, the second and third examples show clearly how the no breaks situation played out. The letter F output included the Morse code for both F and G, since there was no break after the code for the letter F. Since the letter A was the first match, all of the outputs were shown, since there were no breaks to stop the falling action. You might be wondering why breaks are even needed. perhaps asking why the Java designers thought it was necessary to require them. There's a very good reason: flexibility. The option to include breaks or not gives the programmer flexibility to put breaks wherever they are needed, and to take advantage of the falling action feature built into the switch statement. Here is a good example that expands on our Morse code translator program. Suppose you wanted to be able to handle both upper and lowercase letters, but have the same Morse code for both. Check out the next slide. Here, both lower and uppercase letters are listed, but the same outcome happens for either one. When the uppercase B is switched, the compiler finds the match, jumps the fence, executes the output command, and then stops at the break. When the lowercase b is switched, the compiler finds the match, jumps the fence, sees no statement, but falls until it does see a statement, executes it, and then stops at the break.